Hi, this video is to go over problems 8A through D on the test review for test number 2 in Math 3. So for A, you're given this function, this cubic function. So if you think about your possibilities, you could have 3 real or you could have 1 real and 2 complex. To determine that, remember that we always start by graphing our function. So we go to y equals and type it in. It's a good idea to go ahead and put 0 in y2 and make it bold if you want. That way when you graph it, you can find the intersections of any zeros with that horizontal line if you wish. But you can see when you graph it that it only crosses one time, so that tells you that we see that we have 1 real, but the other 2 must be complex. We should verify that it's -2 also by looking at our table. We should not just make an assumption. So let's make sure we check our table and see -2, 0. Being that we know it's at -2, we know we have 1 out of 2 of our 3 answers. So we've got to find the other 2. To do that, we're going to use synthetic division. So we take our x value, our solution here, and put it in our box. And make sure we write out any coefficients and constants across the top row, being sure that we put in a 0 term if any were missing. Remember, for synthetic division, we bring down the first term and then multiply, writing it above the line, add, multiply, subtract here, or I'm sorry, that should be -32. Add and we get 0. So we have x squared plus 16 equals 0. Because this is a quadratic equation without a linear term, we can just use our square root property to solve. So we solve for x by first moving our constant term to the opposite side, subtracting 16. Then we take the square root of both sides. Remember that when you take the square root of a negative, you're going to have I out front. But since 16 is a perfect square, we're going to have 4i. But we have to remember that our square root property says that we could have 2 solutions, so we need that plus or minus there. And these are the other 2 solutions. And each time, you could write plus or minus 4i, but I'm going to write them out so that you can see that we have 3 solutions, which should match the degree of your polynomial. So remember that if you've got 3, you should have 3 solutions listed. Moving on to B, I'm going to go ahead and write this one down. F of x, oops. X to the 4th plus 5x squared minus 36. Please remember that if your polynomials are factorable, you should factor them. We know that this is factorable because we can find factors of 36 that will combine to give us 5, namely 9 and 4. And then we also know that our exponent in the middle is half that of the first term. So we've got x to the 4th, this is x squared, and then a constant. So when we factor, we'll have x squared and x squared. We know that if our constant is negative, 1 is going to be positive and 1 is negative. And the factors of -36 that we could use to get 5 are a positive 9 and a -4. So 9 minus 4 is 5, but 9 times -4 is -36. Remember, when it's factored, all we have to do is set your factors equal to 0. So I'm going to put in here x squared plus 9 equal to 0. You don't have to have parentheses. I don't know why I did that. And then solve, taking the square root of both sides, and we get positive or negative 3i. Square root of both sides, and we get positive or negative 2. So remember, we do have 4 solutions which should match the degree of our polynomial. If we do this by graphing, let's see here, x to the 4th plus 5x squared minus 36. If we graph it, we can see that it appears to cross at -2 and 2, which are the 2 solutions we got here. We can also verify that on our table, which we should always do, -2 and +2. So we can see by the graph that we do have 2 real and 2 complex, and here they are. If you prefer, I would prefer that you do this by factoring. It's a very important skill you need to continue to be able to use, but if you wanted to, you could identify 2 and -2 and do synthetic division twice to end up with positive and negative 3i. Just make sure that when you finish up, you always write out your solutions. Like I said, it's okay to put plus or minus 3i, or you can write them out separate. I'm writing it out so you'll see there are 1, 2, 3, 4 solutions to match our degree of 4. Next, for C, C is a quadratic polynomial. So in order to tell if this is something that we could solve by factoring, remember we could always type our polynomial in at y equals. And let's see what happens. Oh, I saw something pop up here at the top of our screen. So I'm going to zoom out and see what happened. Oh, there's our parabola. But we can see that it does not touch our x-axis. And since it does not touch our x-axis, that tells us that we have two complex zeros. So the best way to find it when we've got a quadratic is either completing the square or quadratic formula. I am going to set this equal to 0 and solve by quadratic formula. So my a value is 3, my b is -5, and my c is +12. Remember, your formula is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a, and you should have that memorized. So if this is the opposite of b and our b is -5, the opposite of b would be +5. Our b squared, please remember to put parentheses around the b before squaring it in your calculator, or recognize that that should just be 25 when you type it in. All over 2 times 3. So what we need to find now is our discriminant value, which because we know that by graphing we should get two complex solutions, we know that we should end up with a negative discriminant. So if I go back here to my home screen, notice how I'm putting my -5 in parentheses with square on the outside, -4 times 3 times 12. And notice also I am not using the square root, the radical, so do not type that in, just type in what's under it. And we get -119. So 119, you might think back to your divisibility rules to see if there are any common factors. It's an odd number, so you wouldn't want to divide by an even. If you divide by 3,
Miss Spellman, if you're in the building,
it's not evenly divisible. Divide by 7. It is divisible, but 7, you've got 7 and 17, both of which are prime numbers, so you do not have any common factors. So the most we can do is, because we have a negative here, put I in front. And these are our solutions. That's 2 of them. 5 plus I square roots of 119 over 6, and 5 minus I square roots of 119 over 6. All right, next I'm going to finish up with D, and then that'll be the end of this video. Let's see. All right, for D. All right, so the first thing we should always do is check our degree. If you notice, we have a degree 6 polynomial here. That means we should get 6 solutions, so keep that in mind. When you look at it, hopefully you notice some common factors among these terms. They're actually both divisible by 3, and they both have at least 2 x's, so we can factor out 3x squared. Now, remember that what you get when you factor out comes from dividing both terms by 3x squared. So 3x to the 6 divided by 3x squared is going to give us x to the 4th power. Keeping our minus here. The 3x squared divided by 3x squared is 1. Hopefully you look at this and also recognize that this is a difference of squares, because 1 is a perfect square and any exponent that's even is also a perfect square. But then that's also a difference of squares, which means this one here will factor into x minus 1 and x plus 1. Now again, if we wanted to, we could, and we probably should, just so we have a better idea of how many are real and how many are complex. Yep, let me hit zoom 6 to set it back to a standard viewing window. All right. right, so it looks like we have, oh, something interesting's going on here. So I'm going to hit zoom to enter so we can really zoom in and see what's happening. It crosses at 1, comes up and bounces off at 0. That should remind you that your multiplicity of that factor will be 2. And then it comes back up and crosses here again at positive 1. So let's see if we can verify that with what we've got. So, and by the way, since we have 1, and this one will count as 2 zeros, so 2, 3, and 4, we know that 4 zeros are real, meaning we should find 2 complex. So if we set each factor equal to 0 and solve, of course you can skip some steps here. But here when we divide by 3 and take the square root of 0, we get that it is 0, but we should recognize that it has a multiplicity of 2. So this is really important. Whenever you have a monomial factor, the degree of your exponent here, of your variable rather, will be the multiplicity. So that's what, and we were able to back that up by saying that it did touch, like bounce off the x-axis there at 0. So our other one from here is positive 1, negative 1, and for this one, when we solve by first subtracting 1 and then taking the square root of both sides, remember your plus or minus, but remember the definition of I is that it's equal to the square root of negative 1. So that's just going to be plus or minus I. So I'll put up here positive I and negative I. So let's count. We've got 1, 2, 3, 4, 5, 6 solutions. It matches our degree of 6, so we should be good. Alright, that concludes this video. The next one will focus on 8E through H, skipping F, of course, and then number 9.